afternoon, everybody, and welcome to MOS Live for our virtual planetarium today, Exploring Space. My name is Karen. I'm one of the many educators at the Museum of Science, and today I will be acting as your moderator. This just means that I will be keeping an eye out for any of your questions, any of your comments, any of your observations that our lead planetarium educators ask of you. Now, the way you can do that if you are here on Zoom is you can find the Q&A button and just type in your comment or question and hit send, and it'll come right to me, and I can share out as many as we have time for. If you are watching on Facebook or YouTube Live, we so appreciate that you're tuning in today, but unfortunately, we cannot field questions or comments from those platforms. And lastly, if you are looking for closed captionings, you can click the CC button and choose Show Subtitles. So with that, I want our other educators to come join me and introduce themselves.
Hi, everyone. My name is Katie. My pronouns are she and her, and today I will be your guide as we travel through the solar system, but I can't do it alone.
Hello, everybody. My name is Talia. I use she, her pronouns, and I will be handling the flying today.
Wonderful. So to wrap up our month of Mars, today we are going to be talking about what it takes to send humans to Mars. So we're going to talk about the challenges, what is already going on, what is planned for the near future, and then what is planned further down the line. And we'll also talk about what it might look like to actually have humans on the surface of Mars, which is always very exciting to think about. So we're starting out right now just by looking at the solar system. Talia is kind of giving us a bird's eye view. And we're going to start by just talking about like the kind of background of Mars to really understand why the challenges are challenges, right? We need to understand more about Mars itself in order to understand what we need to change in order to send humans there. So right at the center there, you can see that is the sun. And then outside from there, we've got Mercury, Venus, Earth, and Mars. So those orbit lines. There's some other labels in there. Those are all various missions that space agencies have sent out, specifically NASA. We're using a program called NASA's Eyes on the solar system, which is free to download. So you can play around with this too yourself if you're interested. So Mars is the fourth planet from the sun. So it's a little bit farther away than the Earth is, actually a lot farther away than the Earth is from the sun. And so it's a lot colder. That's not the only reason why it's colder, but it certainly makes a difference. And Earth is roughly 93 million miles away from the sun. Mars is closer to 150 million miles. Now, taking that difference there is actually not the amount of distance that you would have to cover. It would actually be a much longer distance in order to send anything to Mars, just based on the planet's orientations and also they're traveling, right? They're always orbiting around the sun. So the trip from Earth to Mars is usually on the order of 300 million miles or so. The Perseverance rover that just successfully landed last week, which was super exciting, that spanned about 300 million miles before landing on the surface of Mars, where its entire mission will actually only have it travel about 10 miles on the surface of Mars. So it's done most of its traveling already. But let's get a closer look at Mars now. We've got a good idea of the distance and how far away it is from both the Earth and the sun. And now let's talk about what it's like as a planet. So it's pretty small. It's a lot smaller than the Earth at about half the size. But it does have some of the most extreme surface features in the solar system. Like it's got massive mountains and volcanoes, extinct volcanoes on its surface, as well as canyons. And a lot of what we know about Mars is because of the missions that humans have already sent there. Internationally, there's been a lot of spacecraft sent to Mars. So you can see some of them are orbiting around Mars. We call those orbiters. And then we've also got rovers or landers, which actually go down to the surface. Perseverance was one of them. And you might see a couple other labels as we kind of go through time here, marking the landing sites of several other spacecraft. Like we've got Curiosity coming into view. That was another rover that landed back in 2012, as well as the Insight landing area. So Insight is a lander, meaning that it doesn't actually move around the surface of Mars. It just stays in one place. And there have been several others. And so these are really the key pieces of equipment that have told us everything we know about Mars, in addition to some telescopes from the Earth as well. So it's small. It's got some really big surface features. The atmosphere of Mars is very thin. When you compare it to Earth's, it's about 1% as thick as the Earth's. And it's made mostly of carbon dioxide. So the little atmosphere that is there would be poisonous for humans to breathe. And because of the thin atmosphere and the fact that it's so far from the sun, that makes it very, very cold place. So temperatures, there's a big range on Mars, similar to how there's a really big range of temperatures on the Earth, but they definitely are shifted toward the very, very cold end of the temperature spectrum. It can be anywhere from negative 200 degrees Fahrenheit to negative 80 degrees Fahrenheit. But then in the Martian summertime, it can actually get to around 60 or 70 degrees Fahrenheit around the equatorial region. So there's a really big difference there. But for the most part, it's extremely cold. We also don't see any water, liquid water on the surface of Mars. We do see frozen water or ice in the soil on Mars. We also see it at the polar ice caps. The northern polar ice cap is made of water ice, while the southern polar ice cap is made of carbon dioxide ice or dry ice, which freezes at a much lower temperature. So you can imagine how cold it is there. So not a lot of liquid water really at all. There's some potential underground lakes of liquid water that might be under the southern pole, but no large amounts on the surface at all. It's basically a very cold, dry desert. And so this kind of informs some of the challenges that humans are going to face. Number one, humans have to travel through those 300 million miles from the Earth to Mars in a spacecraft, with other astronauts in a very small, confined space. Traveling that far takes anywhere from 6 to 10 months. If we were to ever send humans to Mars, it would definitely, they would try to send humans on the shorter end of that trip, but it's still 6 months. So that's a really long time to be kind of confined in a very small space. Although now after the pandemic, maybe folks can relate to it a little bit easier than they could before. So that is one of the main challenges. Getting to the moon or getting to the International Space Station, because we've sent humans to the moon and humans go to the International Space Station all the time, but that only takes anywhere from a day or two to get to the ISS and 3 days to get to the moon. So there's a really, really big difference here. Some other challenges, of course, is the temperature. It's cold. We're going to have proper gear, proper spacesuits in order to survive on the surface of Mars. Mars, because it has such a thin atmosphere, it is not protected from radiation. So the Earth has a magnetic field that kind of keeps in the Earth's atmosphere and it protects it from a lot of the radiation coming from the sun. Mars doesn't have one. That's actually part of the reason it has such a thin atmosphere, is that it doesn't have a magnetic field to really protect it at all. So, if humans were to land on the surface of Mars and they would presumably stay there for a good amount of time, if you travel 6 months somewhere, you're going to want to stay at your destination for a decent amount of time. They would have to find areas that either are already shielded from radiation, like a cave or something like that, or underground, or they would have to bring some kind of structure that would help protect them from the radiation. So those are just a few challenges. There are more, but I've talked for a while, so I want to pause and see if any questions have come in so far.
Yeah, I'll start with the last one that just came in since it relates to what we were talking about. Sevi, who is 5, asks, what exactly is radiation?
Yes, that's a really good question. And it's a weird thing to think about because it's not really like you can't see it. It's not really like a physical object, but radiation is light. So light from the sun, that's very, very energetic because there's different types of light, and some light is more energetic than other types of light. And so it's this really, really high energy light that is dangerous to humans. These are types of light that have a very small wavelength. So they can kind of, go into your body and start to mess with things inside of your body. And that's why this high energy light or radiation is dangerous for humans. It's why you have to put sunblock on in the summertime, because you want to protect your body against some of this like UV light or ultraviolet light, or these kind of higher energy wavelengths of light. So I hope that cleared it up.
If you've ever had an x-ray, why the technician who is taking your x-ray steps out of the room, since they're doing it day in and day out, they want to protect their bodies from the x-rays. You getting one x-ray even once a year, even a couple times a year, isn't super dangerous, but for the folks that work there, it can be.
That's a great
So one of the earlier questions that came in, Katie, when you were saying that Mars is small, someone asked how small is it? So maybe how it compares to Earth?
Yeah, it's about half the size of the Earth, a little over half the size of the Earth. So its gravity is less as well. Its force of gravity, it's about a third that of the Earth.
So this is probably for Talia, who is our pilot. Liam, who is 5, wants to zoom in on the volcanoes and canyons, if you can.
Absolutely. I've got the canyon front and center here. Right here.
I don't know if Katie or you want to say anything about it, or we just want to stare at the beauty.
Yeah, that's or you go ahead, Talia.
Well, this is Valles Marineris, which means Mariner Valley. It is the big, huge canyon on Mars. It's, if you put it on Earth, it would stretch across the United States from Boston to San Francisco. So it's over 2,000 miles long, and it is over 7 miles deep, or up to 7 miles deep. And as for the volcanoes, they are very nearby. There are different volcanoes all over Mars, but these are the big ones. You got the triplets right here, one's right in a row. And then the big granddaddy of them all right here. That is Olympus Mons, or Mount Olympus, tallest volcano in the solar system. You would need 3 Everests, 3 Mount Everests stacked on top of each other to equal its height. And if you put it on Earth, it would cover the nation of France. It would cover France.
That is a big volcano. So cool. And another one for you, Katie, maybe. We were talking about the journey for humans to get there. So Freya, who is 11 from Maryland, wants to know, what would they eat on that 6-month trip?
That is a really good question. They would have to bring enough food to last them, but also they don't want to take up too much room when it's already such a small, confined area. So right now, people that are on the International Space Station, they eat a lot of dehydrated foods, foods that can be stored very easily, foods that don't make a lot of crumbs that could potentially harm the astronauts if they breathe in the crumbs, because they're going to be, floating around everywhere. But I don't know. Are there any, Talia, do you know of any like specific foods that they're thinking of having astronauts eat on such a mission?
I don't know about specific foods. I know that one of the things they are doing on the space station is, they're starting to grow some of their own plant foods. So lettuce, for instance, only in small amounts, but the idea is that you would be able to give your astronauts on long space voyages fresh food if they were able to grow their own. So they are experimenting with that on the International Space Station. And that means you don't have to pack, fully grown lettuces. You just need to bring along the lettuce seeds.
Yeah, that would be really important. And for any type of, future human base on Mars, if that were to ever happen, we would need to grow food. It just wouldn't be super realistic to keep bringing shipments over. That would take 6 to 10 months to actually get there.
And be very expensive for a head of lettuce, which wouldn't last 6 months. Probably
Yeah.
not. So Isabella, who's 5, asked a really great question. Is there water on Mars?
Yeah, great question. There is water on Mars. It's just not liquid. So if you're looking for water, you're going to want to look for it in its ice form. So for that, just like the Earth, Mars has polar ice caps. So you want to go and look at either one of these sites, actually just the northern one. The northern one is water ice. The southern one is made up of carbon dioxide ice, which is kind of a weird thing to think about because we're used to carbon dioxide as a gas. But there's also some ice in the soil on Mars as well. And this is actually a potential source of water for humans if they were ever to be on the surface of Mars. Using any resources that they can from Mars is a lot more sustainable than bringing anything that they need. And as we just mentioned, sending things would be very expensive, like food and water. So they would need to find a source on Mars. And so the ice that's in the soil, and some other areas on Mars would be really good spots to kind of tap for that particular resource that is so necessary for humans to survive.
All right, a couple of questions about the volcanoes that we were just looking at. Abigail wants to know, do Mars volcanoes form the same way as on Earth? And Nyan, who's 10 and tuning in from Milan, Italy today, wants to know, are there any volcanoes which are not extinct? So how do they form and are they still active?
Awesome questions. So do they form the same way they do on Earth? Not really. So Earth's volcanoes form because of plate tectonics, which are pieces of the crust that collide and, either one kind of slides down under the other one and creates like lots of energy under there, which can form a volcano as well as earthquakes, or there can be like these little hot spots underneath the surface of the crust on Earth. On Mars, the Martian crust isn't actually split up into pieces. It's all just one piece. So volcanoes don't form because of plate tectonics. And they did form really long ago in the past when Mars was a much warmer place, probably just from in the internal structure of Mars just being very, very, very hot. During the early days of the solar system, when we're talking billions of years ago, Mars, as well as many other places in the solar system, were basically molten rock. And so during this time, volcanoes would have been much more prevalent. And the specific volcanoes that we can see today might have formed from particular hot spots underneath the surface of Mars, but it's not from that actual plate tectonic motion that we're so used to here on the Earth. And then the second question, are there any active volcanoes on Mars? I don't believe we know of any active volcanoes on Mars. It's cooled quite a bit over billions of years. So we don't see any volcanoes that would be able to erupt. Although maybe it's just because we haven't looked at all of them. We're always learning new things from the landers, the rovers. Insight in particular, the lander is one of its tasks is to kind of study Martian geology, so to see what's going on under the surface. And it has measured some Mars quakes, so not volcanoes, but Mars quakes that probably occur from the planet cooling a little bit. And so it kind of causing it to rumble. Those are really good questions, though.
Do you want to take more? Or did you have other things you wanted to talk about?
I do have a few other things that I wanted to show, but I'll kind of cut that down a bit so that we can take more questions if they are coming in.
We still have a bunch here. You could also talk about what you wanted to talk about, and we could end with questions. Up to you, Katie.
Yeah, that sounds good. All right, so we've talked about some of the challenges of getting humans to Mars. It is a very difficult journey, and there's a lot that we have to overcome, a lot of problems to solve before we can safely send humans there and get them back. I did forget to mention that oxygen that humans need to breathe is another huge challenge of being on Mars. As I mentioned, the atmosphere is carbon dioxide. Humans cannot breathe carbon dioxide. They need oxygen. And so one way of getting oxygen for both the crew and to get rockets off of Mars, because if we want to send humans there, we have to bring them back. And rocket fuel, a lot of it's composed of oxygen. So this is another huge challenge that Perseverance is kind of taking some of the first steps to overcome by bringing along an instrument called MOXIE. Now, this particular instrument is going to take the carbon dioxide that's in the atmosphere of Mars and actually turn it into, or split it up into its components of carbon monoxide and oxygen. So it's taking the CO2 and converting it into carbon monoxide and oxygen. And then ideally, we would be able to use this oxygen for both the crew to breathe and for a rocket to get back to the Earth. So I've mentioned a lot of challenges, but they're not just, they're not just barriers that will stay there forever. Scientists are constantly learning more and creating new technologies, engineering new technologies to solve these problems. And MOXIE is a really, really good example of that, or at least of the first steps toward a full solution. So speaking of kind of steps of getting to Mars, there are 3 official steps that NASA has kind of laid out to summarize the entire journey of getting humans to Mars. And the first one is the Earth reliant step. And this one is already happening. And a lot of folks are probably familiar with a lot of the pieces of this. So I'm just going to share a PowerPoint really quickly to show you a picture of the International Space Station. So the ISS is very close to the Earth. It's in low Earth orbit, but it's a place where astronauts can live and work in an environment such as space, in an environment of microgravity. And living and working here provides a lot of insight into what it's like on the human body to be in space for a long time. And this is going to inform, how we're able to send humans to Mars, because humans are going to be stuck in space for a lot longer than just, a few days or even just a few months. So there have been some studies done, like astronauts Mark Kelly and Scott Kelly. They're twins. And Scott Kelly on the right there spent a year on the International Space Station along with a fellow cosmonaut from Roscosmos, the Russian space agency. And his brother, Mark Kelly on the left, stayed at home. So that way, when Scott Kelly could come back, they could compare their DNA, their literal genetics, in order to see if anything has changed, as well as just, seeing other physiological changes that happened to Scott Kelly from staying in space for a year. Some of the things that can happen to the human body, your eyes, your vision can get a bit worse. Your bones and your muscles start to deteriorate over time because of the lack of gravity. And so you're not using your muscles as much up there. So it's something you have to get used to when you're back on the surface of the Earth. So these types of experiments and this type of science is really important before we send humans all the way to Mars. We can do it just next door. The next stage in sending humans to Mars is called the Proving Ground. So this involves, you may have heard of Project Artemis. So this project is the ultimate goal is to get humans back to the moon, including the first woman, but getting humans back to the moon by 2024. Now, this date is probably going to get moved to later in the decade, but the kind of whole goal of this project, in addition to just getting people back on the moon, because it's been a very long time, but eventually is to kind of plot out how to create another space station around the moon called the Lunar Gateway. So this would be a station similar to the ISS that's in orbit around the moon that would function as kind of like a rest stop on the way to Mars. It's really easy to get things off of the moon because the moon doesn't have as much gravity as the Earth does. So sending things off of the moon is just easier. It's more fuel efficient. And if we could create some kind of a base on the surface of the moon, it might be a great stopping point. And we could also study humans living for periods of time on the moon. And again, it is much closer to the Earth. You can communicate with spacecraft, with people that are at this distance much easier than you can on Mars. Mars, there is a very big communication delay. So you are completely independent from any people on the Earth. And that is the last stage of the entire journey, is actually Earth independence. So being completely self-sustaining on your way to Mars. All right, so I'm gonna stop sharing this, and now Talia is gonna show us a cool video of what it might look like in the future to have humans on the surface of Mars after setting up a kind of base camp here. This is a clip from one of our planetarium shows called Destination Mars. And as we watch this clip, if there are any questions, we can take those.
This is great because someone earlier asked if we could virtually get to the surface of Mars. So here we have it in our animation. And I assume that's what it may look like if we set up a really awesome colony on the surface of Mars.
Mm-hmm.
It's not what's there right now.
Definitely not.
Couple other questions. Somebody had asked how Mars got its color, and somebody else wanted to know what were those darker spots when we were looking at sort of that whole sphere of the planet.
Yeah, that's perfect. Those are very related. So the reason that Mars is red is because there's a lot of iron in the soil, and iron, when it's exposed to oxygen, which there's a teeny tiny bit of in the Martian atmosphere, rusts. So if you've ever left a bicycle outside for too long, it gets rusty. Same thing's happening all over Mars. And there are certain areas of its surface that aren't as rusty as others. And those are the darker areas that you might have seen.
Cool. And I think maybe we have time for just one last question. I don't know how much longer the video clip goes on, but somebody was asking, can valuable minerals be possibly found on Mars?
Yeah, so that's actually one of the mission goals of Perseverance, is to look for specific sediments and minerals that may have been preserved in an ancient lake on Mars. So Jezero Crater, the landing site of the Perseverance rover, is thought to be an ancient lake. And there are certain minerals and sediments that can preserve microfossils, or at least that's what happens here on Earth. So Perseverance is going to be looking for these types of materials to see if there's any evidence of ancient life on Mars, because Mars was once a much warmer, more temperate world. And so perhaps billions of years ago, it could have had life on it. And so Perseverance is going to go check that out.
Cool. Now, if anybody's interested sort of in updates on what Perseverance has done in its 5 days on the surface, we actually have another live stream tomorrow afternoon where we're going to have a panel of our museum educators that will answer any of your questions about what the exploration of Mars is looking like right now. So that's at 3:30 tomorrow. You can find the link to sign up to get the Zoom link on our website, just like you did to get here today. But I want to thank everybody for coming and joining us. I especially want to thank Katie and Talia. Oh, there's Talia's lovely face again. For sort of taking us on that journey, really focusing on Mars, which is such a cool planet and one of our closest neighbors. So thank you both. We'll see you next time.
Thanks, everyone.
All right. And I want to thank all of our friends out there who came and joined us today. So thank you for hanging out with us and asking great questions. There were a lot of questions, unfortunately, that we could not get to today. So certainly tune back into another one of these and keep those questions in your head or do some research on your own. You can find out all of our variety of virtual offerings by visiting MOS at Home on our website. And if you enjoyed this presentation and are able to do so, we'd love your support. And you can do that by going to engage.mos.org/welcome. But until next time, thanks so much, everybody. Bye-bye.